Okay, welcome back students. Today we will begin with a new unit that is about wind energy systems. It's a very interesting chapter and its title is like this: Wind Energy Conversion Systems, in which we will come across very novel ideas, innovative ideas by which how wind energy can be converted into other forms of energy like electrical energy in a very beautiful manner. So this way huge amount of electrical energy can be produced, electricity can be produced, and this has been implemented in number of countries including India. India is a global giant in the production of wind energy power farms. So it's important, it's clear from the energy scenario, because our country is a country which faces a lot of energy crisis, and India has immense potential to tap with the wind energy. Innumerable number of areas, regions have been identified by experts where huge wind energy farms can be installed. Okay, so if you go to the list of global giants which produce wind energy, India is one among them. Okay, among other prominents like China, United States, Romania, Sweden, etc., India is at the top. So that shows that we have immense potential to tap the energy from wind. So that is important, and in our unit we will come across different types of breezes, how wind is formed, and what are the different physical principles of wind energy conversion systems, and which are the different parts, components of a wind energy conversion system, and what is and how you can classify actually wind energy system into different groups. Okay, so we will study about how wind energy system can be classified in different types, and what are the different areas where wind energy conversion system can be used. Okay, these are some of the topics which we will come across in this unit. Okay, and it is briefly it is abbreviated as WECS. WECS implies wind energy conversion system. Okay, where it's a system, it's a device by which we can convert wind energy into different other forms of energy. It can be used straight away into other mechanical energy form, it can be into other chemical energy form, it can be directly into electrical energy form. Anyway, we will be mostly focusing towards conversion of wind energy into electrical energy. Okay. So before as a preface, let us have some basic knowledge about how wind is formed. And now all of you know wind is simply a movement, okay, air movement in space, that is called wind, and for its production basically there should be uneven heating effects on the surface. Uneven means in different ways, one side temperature high, other side temperature low. There should be a difference in temperature, then only wind can be blown, wind can be produced. So since the Earth's surface is made of various land and water formation, it absorbs the sun's radiation unevenly. So that is the reason, because there are oceans on one side, lands on other side, other water reservoirs on other sides, rivers, ponds, huge lakes. So land get, or the Earth's surface get heated in different ways, because you know water and land, they are not getting uniformly heated up. They get heated up at different extent, at different temperature scales. So they establish a uneven temperature difference. So this uneven temperature difference also lead to uneven temperature difference in the atmosphere. Atmosphere contains gases. So because of this temperature difference, gas or air moves from one place to other place. That is virtually, that is literally the wind. Okay. So you know, so sun warms the Earth's surface, and so when Earth's surface is warmed, atmosphere also get warmed. some part of the earth receive direct ray from the sun, whereas the other part will receive less. Okay, so that part will be cold, okay, cold regions and hot regions, because sun rays are not falling uniformly over the entire globe. Okay, they fall differently. At a certain point they fall vertically, at that certain point they fall incline, at an inclined edge. So obviously this leads to difference in the temperature. So wherever here temperature is high, what happens? Where the air moves up, air rises up. Okay. So what happens? So from other places, wherever air is cool, from colder place, what happens? The air blows into the warmer place. Okay, warm place, air is pressure is low. At a cold place, pressure is high. So from high pressure region to low pressure region, air blows. This constitutes as wind. And this is obvious from the figure. Okay, Earth is inclined at an angle. You can see Earth is spinning. So at certain places, vertical sun rays are falling. Other place, but inclined sun rays are falling. So obviously, those places will be colder regions, and those places where they are falling vertically, they become warmer region. So from warmer region, as I told you, Earth rises up. From warmer region, Earth rises up. Okay. So red mark is warmer, and so they move towards the colder region, and from colder region what happens? They move to the warmer place. So this way, this cycle of air current, we can call it air current, this takes place over the entire Earth's surface. So thus that constitutes a broader level of wind. Okay, there's a broader perspective of wind. Okay, it's an airflow, continuous airflow. This is happening why? Because of the sun rays are falling at a different angle at different points on them. And you can see the figure, entire Earth. Suppose imagine Earth is spinning here, so this cycle of operation takes place over the entire Earth. So you can say that continuously air on the surface of the Earth is in motion. So this constitutes a global wind. You can see global wind. This cycle of wind occurs over the entire Earth, both on the northern hemisphere and on the southern hemisphere. So this is one of the reasons for prevailing wind on the Earth's surface. Okay. And another reason is land breeze and sea breeze. So let us see one by one what is land breeze and what is sea breeze. First, let us talk about sea breeze. Sea breeze, in fact, simply say, sea breeze is a wind which blows from sea to land. Okay, sea to land. Why this is happening? During daytime, land gets easily heated up. Then sea get slowly heated up, whereas land gets easily heated up. As a result, on the land, air pressure decreases. So what happens from the sea, where pressure is high, the wind blows to the land. So the wind which blows to the land from sea is called the sea breeze. On a hot sunny day, what happens? Differential heating of land and sea. This leads to development of local wind called land, sea breeze. When air above the land surface is heated by radiation from the sun, it expands and begins to rise. Which air? The air on the land, okay, not on the sea, because it is lighter. To replace this rising air, cooler air is drawn in from the surface of the sea. So this is called a sea breeze. Okay, so usually it is very cool. So cool. So sea breeze can offer a pleasant cooling effect on hot summer days. So this is true. If you stand nearby to a sea beach, you can enjoy the sea breeze. It will be mostly cool because it blows into the land from the sea. So that is called a sea breeze. And land breeze occurs at night. At night. So how this occurs? At night, what happens? Sea is comparatively hotter than land. Land gets easily cooled down, whereas sea is hot. So at the sea level, at the sea surface, pressure is low, whereas on the land pressure is high. So what happens? Wind blows from land to sea. Wind blows from land to sea. This is called land breeze. Land breeze. So in this case, at night, air above the warmer surface of the sea is heated and rises up, thereby pulling in air from the colder land surface. So breeze or wind blowing from land to sea is called land breeze, and this is occurring due to this reason. What reason? Air pressure at the sea is less than the air pressure at the land. Because of this, wind blows from land to sea, and this comes to us land breeze. Okay. So now we got the idea about wind. There are global wind and local winds. Global wind is due to rotation of the earth and differential solar radiation at different places. The equator maximum, and towards the polar regions lesser and lesser amount of heat is falling. So there is a global wind, and the local wind is sea breeze and land breeze. Now come to wind energy conversion system. So this is a renewable source of energy, as you know, and you know the total global potential, so which has not yet been tapped, okay, which has to be tapped. So it is of around 11,000 gigawatt. So this much of water, if you can fruitfully convert, so that is enough for the human consumption. But it has not still happened. Gradually we are in the process of converting, process of installing different wind energy farms, and this is around, okay, you see the wonderful data. It is about 5 times the global installed power capacity. Okay, whatever is so far installed, it is much less than 11%. Okay, there are enough potential still existing. And adding to this, you can see, if you explore another area, that is the offshore wind energy farm. It has not still been enormously begun. There are enough offshore potentials still not started. Many countries have started, still it is not at its fullest level. Even China, USA, they have offshore such plants, but that is still not up to the mark. There are enough future potentials. Offshore means you can install wind energy farms in sea, in deep oceans, by installing tall towers. Okay, we start from the bottom of the sea. So such offshore plants are also there. So there are huge potential for offshore plants also. And currently installed global power plant capacity is around 25 gigawatt only. Okay, so we can achieve up to 11,000 gigawatt. So a lot of potential still remain to be achieved. So this is only about 1% of the global installed power plant. So it's a funny thing. Okay, so and you can see the list of global giants again. And India has only achieved 14% of its in the year 2001, its installed capacity is only 1400 megawatt. Okay, 1400 megawatt. Still lot of potential is still that we tapped, and in the years to come, we will see paradigm shift, sudden hike in the wind energy tapping, and we are in the process. And you see that map, these marked areas, shaded areas are the areas where we can install huge wind energy farms, still not completely installed. And even in the Kerala border, Tamil Nadu border also, we have so many places where we can install wind energy plants. And these are all the areas which experts surveyed and found out. Okay. And, now let us come to the wind energy conversion systems. Okay. So it is a device that converts kinetic energy in the wind to usable form of mechanical energy. Okay. So it can be either into mechanical energy or it can be into electrical energy. Okay. If it is mechanical energy, we can use it for different other purposes, like windmills, wind grinding farms, water pumping, etc. Wind energy, yes, you can use for water pumping, you can use for grinding. Okay, in floor grinding, wood cutting, and for AC power generation. Or you can even generate DC by connecting proper solar cells, solar batteries, solar cells. By connecting solar cells, you can charge it and you can use it at day night time. Or you can even convert it directly into AC and connect with the local grids. So that's also possible. And these are typical wind energy farms which we can find in Netherlands, Holland. You can see so many such plants. Even in many European countries or in Latin American countries and in the US, you can see such wind energy mills. In olden times, they used for grinding flours. Okay, flour mills, where they used to powder cereals, okay, wheat, rice, maize, barley, etc. for pulverizing. At that time there were no electrical machines, so they simply used wind energy mills to grind the flours for food purposes. So if you go to history, you will see that there is thousands of years of history, the technology of wind energy, thousands of years, even 5,000 years back, you can say, 5,000 years back, during the time of Egyptian civilization, Nile civilization. Okay, they used such devices to run their boats to the Nile River. Nile River, you know, it's a very lengthy river through which boats were driven with the wind energy systems. Okay, and in AD 1200, Dutch people. Okay, they yes, previous slide I have shown you some video. So such a windmill were established by Netherlands people, Dutch people. Okay, for their various life applications. And in 1700, American colonists in USA, several windmills were installed for various applications, like from water pumping, agricultural purposes, sawmills. Okay, there were enormous amount of forest which was converted into timbers by colony people. They also used windmills. At that time, petrol was not excavated and there were no electrical machines. Only windmill was the option. So, and in 1926, windmill started for electric generation by a French engineer called George Darius. Okay, this was the first electrical machine, wind energy conversion system, which used to convert wind energy into electricity. Okay, thereafter there took place a revolution in the history of wind energy conversion system. So today we had a innumerable number of wind energy machines, different models, different system, different designs. So it is enormous. And these are different parts of a normal wind energy conversion system: tower, rotor, blades, high speed, low speed shaft, gearbox, generator, sensors, power regulation system, like that. So let us see one by one in a simple way. We will not go into much details, only simple ideas we will study. So this is a offshore wind energy farm, okay, where tall towers are installed at the bottom of seabed, on which propellers are connected, and when propellers rotate, they rotate the generator shaft, and from generator current is produced and that is stored or distributed. Okay, so this is an inside view of a wind energy system. We will take one by one. Okay, we will take one by one. First, a rotor. So rotor is something rotating. Okay, this is a rotating one. With 3 blades you can see. So this rotates. So one which is rotating is rotor. So what it receives kinetic energy from the wind. When wind blows, it rotates and transform it into mechanical power. Okay, whose mechanical power? That rotation energy will be used to rotate some turbine inside the generator. Okay, generator. So components of a wind turbine rotor are blade, hub and shaft. So you can see these are the blades, 3 blades. This is the hub part. This is spherical thing, this is a hub. Okay, on the hub these blades are connected. You can have a single blade system, you can have a 2 blade system, you can have a 3 blade system. So mostly people nowadays use a 3 blade system. Okay, and a hub, and the shaft is something, this horizontal rod which connects the generator. Okay, shaft. And there are bearings. Bearings are just to make the rotation smoother, and the bearing will be always applied with some lubricants to make the rotation smooth. So this way they contain blade, hub, shaft and bearing. Okay, that's also clear. And they are designed with single blade, double blade, multi blade, like as I told you. And even 3-blade system I have shown now, and there are more than 3 also. Okay. Rotor with a single blade run faster than and thus create anti-vibration. So single blade system is not widely seen. Rare cases we can see. Okay, and 2-blade system also suffers some problem of balancing. So most people, mostly now designers prefer 3-blade system because of the certain aesthetical aspects also. Some of the wind turbine used for battery charging. Okay, and they have number of blades 4, 5, even 6. Some designs are used for charging battery and for later use of battery, and some designs are used for online supply, okay, direct AC and link to the local grid system. Of course, size of the blade will depend on the power requirement. How much power, whether you want a kilowatt system, whether you want a megawatt system or a gigawatt system, depending on the size, structure, etc. may vary. And blades are usually made up of wood or carbon material, fiber. Okay, we call it fiberglass, like the materials are used to make the blade. You don't use steel because then it becomes heavy. Then using wind, you cannot rotate the fiber. You cannot rotate the blades if the heavy steel is used. So mostly lightweight things are used there. Okay, and most of the large scale systems are made with multi-layered fiberglass blades. Fiberglass is lightweighted, so it can be readily rotated. So, and atoms are made to improve the blade behavior by using different materials. So, research is going on to design new type of blades with much more efficiency. And after rotor and blade, this is the second part, we call it nacelle. Nacelle is nothing but this cover, outside cover. Okay, you can see cover, and inside the cover, under machine is housed. Their machine is housed. So nacelle is simply the outer cover. Nacelle is the cover housing all the generating components of the wind machine, including the generator, gearbox, control system and breaker. So we will study gearbox and control system very shortly. So these are all enclosed inside. Okay. So you can see the nacelle here. This is a nacelle, outside white body. Okay, nacelle. It's a nacelle. So it's a very complex system actually. I will show you another video on working of a wind machine. Then you will see how gigantic, how surprising, how inspiring is the design of the interior of a wind machine. It is not as simple as we see from outside picture. Okay, no, it's very complex. As a gearbox. Okay, a gearbox is used actually. You can see that in a windmill, actually the blades are rotating very slowly. Okay. That slow motion is not enough to rotate a generator. In a generator, the generator system should rotate very fast. Generally, current will be generated. If you rotate it with a low speed, current cannot be generated. So, gearbox is a device which can be used to convert a low rotational speed into a high rotational speed. Okay, it is a device used to convert a low rotation to high rotation. So that is animated here. Okay, in the animation, you can see how a low rotation is converted to a high rotation. So that device, the gearbox is important component in the power transmission of a wind turbine. Speed of a local wind turbine is around 30 to 50 rotations per minute, whereas generator should rotate at 1000 to 1500 rotations per minute. This is made possible by using gearbox. It's a mediator which convert the blades to low speed into generators high speed. Okay, it's a mediator actually. So gear are fitted in the transmission line to regulate the speed according to the requirement of the generator. Okay, so this is shown here. Okay, how a low speed is converted into high speed using a gearbox. The same gearbox you can see even in a vehicle, in a car or a bus, where you can see gear. By rotating the gear, we can control the speed. So if you want to speed up the motion of a car, you can put the gear at different levels. But also what we are doing is by moving the lever, we are connecting the engine rotation to different rotation speed. Okay, there are different rotational wheels having different speeds with which you can control. Accordingly, the vehicle speed can be increased or reduced. You can gear down or you can gear up. Accordingly, the speed of the vehicle will increase. Same principle is used in a windmill, where rotation speed of the vehicle is controlled using a gearbox. Okay. So an ideal gear system should be designed to work smoothly and quietly even under adverse climatic conditions over the lifespan of the car. Okay, so that is for that proper lubrication is given, because every now and then you cannot open a nozzle by climbing upon a windmill. It is not very easy. So proper lubrication should be given and should be lasting. Should be properly working for 30 to 35 years. So it is accordingly made. High quality grease is applied to the bearing for its trouble-free motion. Okay. Due to finite size of the nozzle, size of the gear system should also be critical factor. So gear should be properly designed in order to accommodate them in the nozzle. Okay. So this is a particular type of gear system used in windmill called planetary gear system, and that is what is shown here. The same planetary gear system is shown here, by which a rotation is executed. And so this is exactly how the gear, planetary gear looks like, and this is used inside the windmill system. So here is the assignment now. Explain the relevance of rotor, nozzle and gearbox in a wind energy system. This is one question. And the second question is distinguish between sea breeze and land breeze. Okay. So you can try any of the question or both questions. It is up to you. So with these comments, let's stop today's module. Thank you all.